Have you ever wondered about the secrets of our neighboring planet Venus? What if we told you that lightning there is unlike anything we've ever imagined? Venus, often referred to as Earth's sister planet, due to its similar size and proximity to our planet, has long fascinated scientists, astronomers, and space enthusiasts. Over the years, several mysteries have arisen about Venus, some of which have been resolved, while others remain subjects of active research. Here are some of the many secrets and curiosities of Venus. Venus has an incredibly thick atmosphere, mainly composed of carbon dioxide with clouds of sulfuric acid. This dense atmosphere creates a runaway greenhouse effect, making it the hottest planet in our solar system, even hotter than Mercury, which is closer to the Sun. Unlike most other planets, Venus rotates in the opposite direction. This means that if you stood on Venus's surface, the Sun would rise in the west and set in the east. The reasons for this unusual rotation are still a topic of debate. A day on Venus, from one sunrise to the next, is longer than a Venusian year, the time it takes Venus to orbit the Sun. This is due to its slow rotation on its axis. The atmospheric pressure at Venus's surface is 92 times that of Earth, equivalent to the pressure found 900 meters underwater on Earth. There are continent-like highlands on Venus named Ishtar Terra and Aphrodite Terra. The origins and geology of these regions are subjects of ongoing research. Venus hosts many shield volcanoes. Some data suggests that volcanic activity could still be ongoing, but this is still a subject of debate. Despite early hopes of Venus being a tropical paradise, space missions revealed it to be a hellscape with no liquid water. However, Venus might have had liquid water oceans in the distant past. The atmosphere of Venus exhibits a phenomenon called superrotation, where it circles the planet in just 4 Earth days, much faster than the planet's rotation. These winds move at hurricane speeds and can whip up to 224 miles per hour. Dark streaks seen in Venus's clouds have puzzled scientists for years. They absorb ultraviolet light, and their exact composition and origin remain unknown. These are unique, highly deformed regions on Venus's surface that appear like tiles. They are believed to be the oldest features on the planet, but their formation process is not well understood. In 2020, astronomers detected phosphine, a potential biomarker in Venus's atmosphere. While this sparked discussions about the possibility of life, further research is needed to understand the phosphine's origin, whether biological or non-biological. The Parker Space Probe. Launched in 2018, the Parker Solar Probe's primary mission was to study the Sun. The Parker Solar Probe is named after Dr. Eugene Parker, the astrophysicist who proposed the existence of the solar wind in the 1950s. The Parker Solar Probe will come as close as 3.83 million miles or 616 million kilometers to the Sun's surface, within the outermost part of the corona. In comparison, Earth's average distance from the Sun is about 93 million miles. The spacecraft is equipped with a cutting-edge heat shield called the Thermal Protection System. This shield can withstand temperatures outside the spacecraft reaching up to 2,500 degrees Fahrenheit. At its closest approach, Parker Space Probe will be hurtling around the Sun at approximately 430,000 miles per hour, or 700,000 kilometers per hour. That's fast enough to travel from Philadelphia to Washington, D.C. in just 1 second. The primary goal of the Parker Solar Probe is to unlock the mysteries of the Sun's atmosphere, or corona, by getting closer to the Sun than any other human-made object before it. One of the primary aims of the Parker Space Probe is to trace the flow of energy that heats the corona and accelerates the solar wind. The solar wind is a stream of charged particles released from the Sun's surface, which can affect space weather and, in turn, conditions on Earth. The Parker Space Probe aims to travel through the Sun's corona to study the magnetic fields at the sources of solar wind. By doing this, scientists hope to understand why the corona is significantly hotter, millions of degrees, than the Sun's surface. The probe will study the mechanisms that accelerate and transport solar energetic particles. These particles can reach high energies and pose radiation threats to astronauts and electronics in space. Understanding the structure and dynamics of the magnetic fields at the sources of solar wind is crucial. These magnetic fields can cause solar flares and other solar storm activities. So what is the connection between the Parker Space Probe and Venus? The Parker Solar Probe utilizes Venus for gravity-assisted maneuvers. These maneuvers are a crucial component of many space missions, as they allow spacecraft to save fuel and energy by leveraging the gravitational influence of a planet. Each close pass to Venus allows the Parker Solar Probe to adjust its trajectory, By using Venus's gravity, the probe can more efficiently alter its orbit to get closer to the Sun during subsequent orbits. To achieve this, the spacecraft requires multiple gravity assists from Venus over its 7-year mission. Each encounter gradually reduces the probe's perihelion, or its closest approach to the Sun. Gravitational assist is a highly efficient method to adjust the trajectory of a spacecraft without expending much of its onboard fuel. This not only conserves resources but also extends the potential lifespan and operational capability of the mission. Along with changing its distance from the Sun, the gravity assists also allow the Parker Solar Probe to slightly adjust its orbital inclination. This gives the probe diverse vantage points for studying different regions of the Sun. Although the primary objective of PSP is to study the Sun, any approach to a celestial body offers a unique opportunity for scientific observations. During its flybys of Venus, the probe can gather data on Venus's atmosphere, magnetic environment, and other phenomena, albeit not as its primary focus. But on its numerous gravity assist flybys of Venus, it discovered something startling. Lightning on Venus, but not just ordinary lightning. It's different, it's more intense, frequent, and is interwoven with the planet's thick, toxic atmosphere. There have been past missions and observations from Earth that have hinted at the possibility of lightning activity on Venus. For example, missions like the Soviet Union's Venera probes and the US's Pioneer Venus orbiter in the 1970s and 1980s provided some data suggesting the possibility of lightning on Venus. Furthermore, the European Space Agency's Venus Express, which orbited the planet from 2006 to 2014, found evidence of Whistler waves, which are electromagnetic waves that could be associated with lightning. Research shows Venus's lightning is up to 10 times more powerful than that on Earth. This is partly due to the planet's dense atmosphere made up of carbon dioxide, with clouds of sulfuric acid. But what's truly fascinating, the Parker Solar Probe found that these lightning events might play a crucial role in renewing Venus's surface, leading to a better understanding of its geological history. And why is this significant? Because understanding Venus's atmospheric phenomena can lead us to deeper insights about exoplanets and other star systems. Understanding lightning on Venus can provide insights into atmospheric processes not only on Venus but also on Earth and other celestial bodies. Comparing atmospheric phenomena across planets can offer clues about their respective evolution and current dynamics. Lightning plays a role in atmospheric chemistry by breaking down molecules, which can then recombine in new ways. Understanding lightning on Venus could provide insights into its mysterious and thick atmosphere's chemical processes. The exact mechanisms and processes at play in this dense atmosphere, including the role of lightning, remain subjects of scientific curiosity. While Venus is considered too hot and hostile for life as we know it, understanding all aspects of its atmosphere, including phenomena like lightning, can aid in our broader understanding of planetary habitability. If we can decode the mysteries of our neighboring planet, imagine what it means for discovering life possibilities elsewhere. So, the next time you gaze up at the night sky and spot Venus, remember, there's a lot more happening than meets the eye. Our universe is filled with secrets waiting to be uncovered. Let's keep exploring, keep questioning, and keep marveling at the wonders above and beyond.